Okay, these exercises are out of the reveal text, the word problem section. For number 12, we want to find the largest angle. So the largest angle is going to be opposite the largest side. The largest side is 53 feet, so angle 2 must be the largest angle. For number 13, these two people live on the same straight road, and assuming that their balconies are both the same height off the ground, like we'll look at the picture there, and they're both looking at the same angle down to the flagpole, we can assume that they must be the same distance away from the flagpole. And there's actually a angle side. There's an angle side angle pattern, assuming the balconies are the same height, that says that those two triangles are congruent, which means that the hypotenuses are both congruent, which means they're the same distance away. So for number 14, finding out what the angle is between Abilene and Dallas at Austin, subtracting 64 and 59 from 180, we get 57 degrees. So that angle is 57 degrees. So the longest side is going to be opposite the biggest angle. Opposite the Dallas angle is going to be the longest side between Abilene and Austin for the distance. The shortest distance then is going to be opposite the smallest angle, which is going to be between between Abilene and Dallas. So the two cities that are nearest are on the shortest side. The cities that would be furthest would be on the largest side. And that's what we're going to need for B then. So again, Dallas, Abilene are the closest from the cities on the map. And then we're going to see that for the largest distance between the cities, it's got to be between Abilene and Austin. And for this to work, you have to assume that there's pretty much a straight highway distance, straight line between the cities to kind of set this triangle up. So that's the other thing that could kind of throw the measurements off, is if the roads kind of meander around a little bit. So that's part C. You have to assume that the roads are straight between the towns. Okay, looking at numbers 15 and 16. This is starts out being a triangle sums problem, and once we figure out what x is, we can figure out what the measure of each angle is, and then we can use those to compare the angles and the sides in order from smallest to largest. So if we add the x's up, we get 4x plus 90 and another 10 makes 100. So 4x plus 100 makes 180, which is going to be 4x is equal to 80, which is going to be x is equal to 20. So the angle at x is going to be 41 degrees. The angle at y is going to be 49 degrees. And then we have the 90-degree angle at z. So if we rank order the angles, the 90-degree angle is going to be the largest, the 41-degree angle is going to be the smallest, and the 49-degree angle is going to be in the middle. So talking about the sides then, opposite the 90, well, if we're going from smallest to largest, opposite the smallest angle would be side ZY or YZ. Opposite the medium size angle would be side XZ, and opposite the largest angle, the 90-degree angle, would be side XY. So that's how we could rank order those from smallest to largest. And pretty much the same thing goes on for number 16. If we add the x's up, we get 4 x's, and then numbers we get plus 8. So 4x plus 8 is equal to 180. Take away 8 from both sides, we get 4 x's is 172. Divide both sides by 4, we get 43. So x is going to be 43. So one angle is going to be 89 degrees. The other angle is going to be 42 degrees, and one angle is going to be 49 degrees. So in order from smallest to largest, angle P is smallest, angle Q is next, and then angle M is largest. The side opposite P, MQ, is going to be the smallest side. The medium-sized side is going to be MP, and the largest side is going to be PQ. Okay, moving on to 17, 18, and 19. Using the given information, AY bisects angle A and BX bisects angle B, and Q is at the intersection. If we suppose in number 17 that side BC is greater than side AC, and we look at the angles, we can pretty much figure out from BC being larger than AC that angle A is larger than angle B. So if those angles are both bisected, 1/2 the measure of angle A is still going to be bigger than 1/2 the measure of angle B. So that's how we could do number 17. We'll get that filled in. So looking at number 18, the claim is that XC is congruent to YC if BC is larger than AC. So if we look at BC being larger than AC, BC being larger than AC sets up angle A larger than angle B, but using the angle bisector is not the same thing as the perpendicular bisector, so we don't know for sure that, first off, that those segments were congruent to begin with, and also that the segments being bisected, still we don't know for sure that they're going to be congruent. So that argument is actually incorrect. If we look at number 19 and assume that the measure of AQB is larger than the measure of BQY, the question is, though, which side of ABQ has the largest length? Well, ABQ is actually just that triangle in the upper left corner, and that's really the size of the sides is really controlled by like angle Q, angle A, and angle B for the sides in that triangle. So if the largest angle at the center, AQB, really has no relation with BQY, AQB is the largest angle, so side AB is going to be the largest side. So the BQY greater than measure stuff really doesn't make any difference for this problem. We're just dealing with that one upper left triangle there. So the obtuse angle has to be opposite the largest side. Okay, we're going to skip over the proof for number 20. And then if we look at number 21, the squares at the bottom, they're asking about which square has the largest perimeter. And there is some information about the angles that are in the triangle that make up the square. So we can figure out what all the angles measures are by doing triangle sums. Let me scroll that up so we can see it better. So we have a 47 and a 54. That adds up to 101. Take that away from 180, we have 79 degrees. The 79-degree angle is the largest angle, so shape 3 is going to have the longest side. That's opposite the 79. And the medium size shape is going to be opposite the 54. And the smallest square is going to be opposite the 47. So the largest square is going to have the longest perimeter. The shortest square is going to have the shortest perimeter. And so the question wants us to order the squares in order from the one with the least perimeter to the one with the greatest. So we have a 2 is less than 1 is less than 3 for the perimeters of those squares. Using the figure at the right, this deals with the exterior angle side inequality theorem. The exterior angle is greater than or equal to the sum of the remote interior angles, or either one of the remote interior angles. So angle 1 is going to be greater than 5 or 6 because those are remote interior angles to angle 1. Angle 2 is going to be greater than 4 and 6, or 4 or 6. Angle 7 is going to be greater than 4 or 5. Angle 3 is going to be greater than 11 or 12. Now, when we get to 26 and 27, though, it's a little bit different. What's going on with that is we can see that angle 3 is obtuse, and those other angles are acute. They're actually on the other side. They're not really like exterior angles or remote interior or anything, but those obtuse angles have to be bigger than the acute angles. So that's what we get for that.